Most people throw more compute at hard problems. I'm trying a different approach. Change the frame we use to look at the problem so the structure in the decay shows up instead of getting smeared out as chaos. That's what my Goldbach Topographical Calculator and egocentric reference frame are about. Hello, Andrew, and anyone else watching. I'm Thomas, an autistic/ADHD independent researcher and voice actor. A little while ago, I stumbled into a visual way to explore the Goldbach conjecture, and within 4 days of that initial discovery, I built this tool I call the Goldbach Topographical Calculator. I'm not a conventional academic or ML engineer. I'm trying to give builders and investors a visual way to see entropy not as pure chaos, but as structured decay, where and how the falling apart is organized. This is the Goldbach Topographical Calculator. Very briefly, Goldbach says, every even number greater than 2 can be written as the sum of 2 primes. Instead of checking that with brute force, I treat each valid decomposition as a point in a landscape. Along this axis, you have the even number you're testing. Along this axis, you have one of the prime components. And the z-axis, the height/color, is a Shannon-style entropy lens. Very roughly, you can think of Shannon entropy like the telephone game. The more ways a message can get scrambled as it's passed along, the higher the entropy. I'm using a logarithmic version of that idea to measure how scramblable or information-dense each Goldbach decomposition is from the observer's point of view. The height or color at each point encodes how that decomposition behaves under my egocentric reference frame. When I move through the landscape, I'm not just seeing yes/no for Goldbach. I'm seeing patterns, ridges, valleys, repeating structures that stay stable even when you change scale. This is what I mean by structured decay. In this frame, entropy isn't just randomness. It's decay with a pattern. The landscape lets you see where that decay concentrates and how it organizes itself, instead of treating everything as white noise that just needs more GPU. I'm still early in formalizing all of this, but the important point for a founder/investor lens is, this is an actual working artifact, not a thought experiment, as thoroughly documented in the GitHub. By egocentric reference frame, I mean this. 0 in this landscape is my origin as an observer, the point I'm standing at. The Goldbach Topographical Calculator shows what the mathematical world looks like when you look outward from that origin toward the horizon. So instead of a God's eye global coordinate system, ERF is anchored to a finite observer with limited reach. Every point in the landscape is, how hard is it to see or reach this from here with these particular limits? That's why I call it egocentric. It's centered on the observer, not the universe. In ERF, every coordinate already bakes in those limits, so entropy stops being just chaos and becomes structured decay relative to that agent. Some regions of the landscape are effectively smooth and easy for the agent to traverse. In other words, it is close to that observation point, the observation point of the agent, while others are jagged and effectively impossible. The calculator encodes that in the heights and colors, What you're really seeing is how the problem looks when you force it through the bottleneck of a bounded mind. In practice, with the calculator, ERF is implemented in how I map those decompositions into that landscape. When you look through this lens, the landscape of valid Goldbach decomposition stops looking like random noise and starts looking like something with reusable structure in how the decay behaves. Right now, areas like nuclear fusion control or AGI safety are classic examples of systems that look chaotic and hard to stabilize, so everyone keeps throwing more compute and more parameters at them. I'm not claiming ERF magically solves those fields. What I'm saying is, if you treat entropy as structured decay from the point of view of a bounded agent, you get a different handle on where instability comes from and how structure concentrates. The Goldbach calculator is a concrete sandbox where that idea works. My bet is that this lens could be one of the missing ingredients in bigger, real-world systems where stability is everything. If you invest in people and tools at the edges of what's computable, a different way of parameterizing difficulty, entropy, and structure might be more important than squeezing out another 5% from existing architectures. If this resonates at all, the easiest way to go deeper is 1. I can record a more technical follow-up, walking through specific slices of the landscape you'd find most relevant. Or, if you're open to it, I'd love to have a short conversation about how to translate this kind of structured decay lens into something legible for operators and investors. Either way, thanks for taking the time to look. I know your attention is expensive, so please like, favorite, and subscribe for more Theory of Everything.